welcome to another beautiful day in geometry class. Today we get to talk about two-way tables. A two-way table is a table that records data as it pertains to two different categories. In a two-way table, you can see the results of a survey, which we had students that were asked about their gender, are they male or female, and then their dominant writing hand, are they left or right-handed? Okay, so in our table, you can see our data split into the 4 columns. So those individual data, so that stuff in the middle, okay, so all of our specific data points, okay, the stuff highlighted in yellow, that is considered our joint frequencies. Those are the individual data entries. Think about like your elbow joint or your knee. It's where my humerus and my radius and ulna come together. So in our table, so like the number 7, that is where males that are left-handed, that's where their data is represented. And then on the outsides, so let's go ahead and highlight joint frequencies in yellow as well. Okay. And then on the outside, you have your marginal frequencies. And marginal frequencies are these pieces here. Oh, Peter. Oh, no. All right. Whoa, 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 whoa. Calm down. Calm down. Let's just go one line at a time. Because it wasn't dealing with that funky looking figure, huh? Okay, so those are marginal frequencies. Think about like the margins on a paper or when you're typing and you can set your margins. It's the edges, it's the space around that surrounds the numbers you're putting in. So we can calculate our own marginal frequencies and just simply we're going to add our data together. So the number of left-handed individuals that were surveyed is just 7 plus 9, which of course is 16. The number of right-handed individuals is 48 plus 86, which is 134. The number of total males that were surveyed would be 7 plus 48, which is 55. And the number of females would be 9 plus 86, which is 95. And then the bottom right corner is going to be the totals of all the individuals surveyed. And we add up the whole bottom, the 16 and 134. And then the top, 55 and 95, we get a total of 150 people that were surveyed. Now we can use these data points, okay, we can use this data to help us understand what's going on. So this first problem, we're just going to fill in the missing data. Okay. Upon exiting, the passengers on the plane were asked if this was their final destination, if they checked any bags. So they've got a yes or no, it was their final destination, or a yes and no, did they check bags? We're going to complete the data and we're going to fill in our missing pieces. So the first one I see here, I'm just going to go top to bottom, is final destination, no. That's a blank. But we have our 50 and our 136. So we can take those two numbers and get the difference, which would be our actual answer of 86. And then the others are all just marginal. So we can just add them together. So 50 plus 16. So we got 66. 16 plus 48. 64. And then of course we add everybody together. 66 and 134, 136 and 64. And we get 200. So we can use this data to determine whether or not we're going to have any frequencies. So we're going to take the data from the checked bag's final destination and we're going to determine if we have some frequencies. What percentage of time is this occurring? And to do that, we're just going to take the number in each box, so the 50, the 86, the 16, the 48, the 136, the 66, the 134, and divide it by the total. So we want to know what percentage of our population is this box assuming. So we're just going to go through and we're going 50 divided by 200. And we get 0.25. And then we've got 86 divided by 200 to be 0.43. 16 divided by 200, which is 0.08. 48 divided by 200, 0.24. Okay, and now those data points, we could add them up and get our totals, or we can also do the edges. Now what happens is sometimes because of rounding, when we add them together, we're a little off. So it's just safer to just go ahead and do that. So 66 divided by 200, 0.33. And then if you look, 0.25 plus 0.08 is 0.33. Same thing, we're going 134 divided by 200, which gives us 0.67. 136 divided by 200 is 0.68. And then 64 divided by 200 is 0.32. And guys, you can add it up, 0.25 plus 0.43, 0.68, 0.08 plus 0.24, 0.32, 0.33 plus 0.67. And then down here in the bottom, it would be 200 divided by 200. So this should always be 1.0. Every time, that bottom right corner should be 1.0 because it's 100% of the entire population from this data set. Okay, now that we know how to set up our two-way tables, how to get our joint frequency, we can go ahead and do some probability out of it. We're just going to have some more fun. Okay, we need to find out how many total people existed. Okay, so we're going to add up our 4 data points. So 62, 20. You know what? Just because I want to, let's go ahead and add these points. 62 and 20 is 82. 28 and 15 is 43. 62 and 28 should be 90. And then 15 and 25 is 35. I'm just getting the marginal frequency because I see that given, and it's going to help us out a little bit without having to do, you know, those extra practices. And then, of course, we can add those two together. 82 and 43 is 125. 90 and 35 is 125. So our total was 125. So that's our total population. Okay, what is the probability that somebody does not practice? Okay, so there is no limit. So they're talking about the whole situation. So our whole population is 125. And of those 125, 43 students did not practice. And then we would, of course, math bracket. It probably is already reduced. It is. And then, of course, this data can be represented as a decimal or a percentage. Guys, anytime we represent probability, that data can always be represented one of those 3 ways. Hey, what about practices and rents? So they want people that practice and people that rent. So we go to our table. We want to find out, where do those two individual data points come together? So people that practice and rent, well, there's 62 of them, and that's out of our total population. So 62 over 125. Math bracket to make sure it doesn't reduce. It doesn't, which of course can be represented as a decimal or as a percentage. Now here comes the conditional stuff we talked about. Remember conditional probability, we talked about, hey, we are limiting our sample. We are taking the total population, and because we're doing a given now, we're going to limit that population. Okay, and then remember the second piece of our given, that's the constraint we're going to work on. Okay, so we want a probability that somebody does not practice given they own a piece of equipment. So in our data, how many people owned a piece of equipment? And that would be 35. So 35 people owned a piece of equipment. And of those 35 individuals, 15 of them did not practice. Now, of course, this guy's going to reduce. Looks like 5 goes into 15 3 times, 35 7 times. Okay, and of course, that data can be represented as a decimal or a percentage. And remember, guys, probability will always be within 0 and 1. Probability can never be greater than 100. It can never be less than 0. All right, last one. Probability that somebody rents given they practice. There's our reduction. That's who's limiting us. So how many people practice? And that would be 82. And then now we're only looking at that column of people who practice. Okay, of those 82 who practice, 62 of them rented. Go ahead and math frac that rascal, 31 over 41, which of course we can express as a decimal, 75, 61, or as a percentage, 75.61. It's not that bad, right? Yeah. Let's go ahead and down to number 6. Number 6 does it a little different. Okay, it wants us to fill out our joint frequency, and let's see if we can't see some relationships. Restaurant has chocolate, strawberry, or vanilla ice cream available in a cup or a cone. The table at the left gives us our choices of 200 people. So we've got all the data we need to. We don't got to do it on our own. We need to complete the table with joint and marginal frequencies. That's now where we're going to divide the number we got divided by the total, and then we're going to find the probability. Okay. So there were 42 out of 200 chocolate, 55 out of 200 cone, 28 out of 200 strawberry, 22 out of 200 strawberry cone, 18 out of 200 vanilla, 35 out of 200 vanilla cone. Hey, and again, guys, I'm just going through trying to get all this data set up. 42, 28, and 18, we add those together. 42, 28, and 18. We know 88 people want a cup. 55, 22, and 35, 112 wanted a cone. 42, 55, 97 wanted chocolate. 28 and 22, 50 wanted strawberry, and then 18 and 35. 53 wanted a vanilla, right? Add them up, make sure that we get both columns and rows give me 200, and it does. And then of course we can go through 88 out of 200, 112 out of 200. Because guys, this is just our frequency. And now maybe we can connect the dots. We're like, holy cow, frequency is just probability. It's pretty magical. And of course, 200 out of 200. That bottom corner should always be 1.0. Now let's go ahead and fill in our frequencies. Do it in red so we can kind of see. So 0.21, 0.275, 0.485, 0.14, 0.11, 0.25, 009, 0175, 0265, 0.44, 0.56, and of course 1.0. So the red is all of our marginal and joint frequencies. Okay, now let's take a peek. Probability that somebody will select a cone. Well, if I go to the bottom where we had cone, look at that. My probability is given to me. So I know it's 0.56 or 56%. So because there's potential rounding, we're not going to deal with the fraction. Okay, cup or chocolate. Now we can do, we need all the people that chose cup, all the people that chose chocolate. Okay, so we're going to add up the cup people with our chocolate people. So 0.44 plus 0.485. Now here's where we talked about it the other day. So let's go ahead and highlight this column just because it's that important, okay? I'm going to highlight. So we want people that chose cup or, okay, people that chose chocolate. What do we notice about those highlighted pieces? Well, hopefully we notice that that data point, people that were cup and chocolate, is counted twice. So when we do this probability, okay, so we want probability of cup, okay, plus the probability of chocolate, okay, but because we had a double count, we've got to subtract the probability of cup and chocolate. So it's just 0.44 plus 0.485 minus 0.21 because that data has already been calculated once. We cannot calculate it twice because it's going to skew us. Okay, 0.485 plus 0.44 is 0.925 minus 0.21, and we get 71.5 or 71.5%. That's the hardest part on this, okay? What about strawberry given they like cones, okay? So here comes our conditional probability. So we got to do the probability of strawberry and cone over the probability of just cone. So the probability of strawberry and cone was, let's find it out, 0.11. We can go to our chart. So strawberry and cone, this guy right here, was 0.11, and the probability of just cone was 0.56. Pop that into the L calculadora, and we get 0.1964. Okay. And then cup, not vanilla. So we want the probability of cup and not vanilla divided by the probability that it's not vanilla. Now this makes a little extra. So in our data, 0.265, so if we talk about, remember our complement, and to get the complement, the not, okay, we're going to go 1, which is the total probability, minus the probability that it does happen. So the probability that somebody got vanilla was 0.265. So 1 minus that would be 0.73, 0.735. Okay, and then how about the probability that they got a cup and it wasn't vanilla? So cup and not vanilla would be strawberry or chocolate, right? So we take that 0.56 and we're going to subtract the vanilla, which gives us 0.35. So we got 0.35. Remember, that's cup and not vanilla. Sorry, that was, let's rewind a little bit. So we talk about the cup portion, correct? Okay, so we take that data. So this was our total probability of a cup, and we're going to eliminate that one. So you can either add these two together to get it, or you could subtract from that. It's up to you. It's whatever you're more comfortable with. Okay, so that'd be 0.35, and then we found out the probability of not vanilla was 0.735. Pop that into the El Calculadora, senoras and senoritas, and we get 4762. Guys, that concludes our lesson on two-way tables. Go be great.